students, how are you all? So today we are going to continue with the part 2 of the chapter motion and time. That is, we are going to continue in this chapter about the numericals and the NCERT exercise. We are going to cover up those. So as we have learned in the previous section about the formula which was regarding the speed, and also we have learned about the pendulum, simple pendulum. We are going to take all those numerical questions. So without any further ado, let's get started. So dear students, before we are going to continue to solve out the numerical problems, we need to know some formulas. Alright, we need to revise them so that we can do the numericals questions correctly. Alright, so the very root formula which we have already learned, that is the formula of speed, right? So that was speed is equal to distance upon time, right? So this is going to be the root formula from which we are going to derive the formula of distance as well. So that would be speed multiplied by time, right, is equal to distance upon speed. All right, so these are the common formulas we are going to see, and then we are going to see some questions regarding simple pendulum as well. All right, so in this simple pendulum, the questions may ask you to calculate the time, all right, time period of the whole oscillation. Like you have a simple pendulum, looks like this. There is a string and there is a bob which just move on to and fro motion, right? So in this they will ask you to calculate the time period, which formula goes like total time taken upon number of oscillations. All right, so we are going to focus on all these formulas in order to calculate the numericals. All right, so alright, so your first question goes like, a simple pendulum takes 32 seconds to complete 20 oscillations. What is the time period of the pendulum? So you can simply see right here the time taken to complete 20 oscillation is given to you, that is 32 seconds. Alright, so we have mentioned here 32 seconds. Then time taken to complete one oscillation would be goes like, so the formula you already know that we have studied. Time period is equals to total time taken upon number of oscillations, right? So we just going to put the data in this formula. So it will be like 32 upon 20 and the answer is going to be 1.6 seconds. So the time period of a pendulum taken by it to complete one oscillation will be 1.6 seconds. So this formula, you need to put the data inside this formula and you will get the answer. All right, let's see the second question. All right, so here it said that the distance between two stations is 240 kilometer. So you need to mention here first distance which is given about 240 kilometer, right? And then a train takes 4 hours to complete the distance. So the time is already given to you, which is 4 hours, right? So you need to calculate the speed. So here the formula should be speed is equals to distance upon time taken, like this. And you need to mention what is given to you, that is distance which is 240 kilometers and time which is 4 hours, right? So you will get the answer 60 kilometers per hour, right? So you just need to put, you just need to know the formulas and you are good to go. All right. Now let's see the next question. All right. So there is an odometer of a car which reads 57321.0 kilometers, and when the clock shows the time 8:30 a.m. So what is the distance moved by the car if at 8:50 a.m. the odometer reading has changed to this? So calculate the speed of the car in kilometer per minute during this time. Express the speed in kilometer per hour also. So what we will do in first since you can see there are two distance given. So you need to mention the middle distance, means you need to subtract these two distances in order to get the net distance covered by the car. So what you will do, first we will take this one, (6.0) minus 5732.1.0, which is going to be approx 15 kilometers. All right. So, and you can see there are two times also given, 8:50 a.m. and 8:30 a.m. So you need to make the mid time, which is going to, you here also you're going to minus 50 minus 30, which is 20. And then what you have to do, now you have to put the formula speed is equals to distance upon time taken, and then it will goes like 50 upon 20, then 3 upon 4 kilometers per hour, right? So in this way you have mentioned the kilometers per hour. And then now the thing is, here you have to the question says that you need to express the speed in kilometer per minute as well. So what you will do here, 1 hour 60 minutes, like this. All right. So 1 upon 60 into 20, you will get how much? 1 upon 3, right? So here you're going to do like 15 upon, in this space of 20 you're going to write 1 upon 3. So you will get like this, 15 multiplied by 3, which is going to be your 45 kilometers per hour. All right. So what we have done in this question, first we need to know the distance. So we have subtract the odometer speed here, like 57336.0 minus 57321.0 means the final distance is being subtracted with the initial distance, right, in order to get the net distance, right? And then there also time are two times are given. So here we need to know the net time, the middle time. So we have subtract here as well, and then when we get the values of distance and time, we just have put in the speed formula, and we have calculated the distance in kilometers per hour. All right. All right. So now we will see the next question. All right. So the question is, Salma takes 15 minutes from her house to reach her school on a bicycle, right? So Salma is going to school by her bicycle. All right. So if the bicycle has a speed of 2 meter per second, calculate the distance between her house and the school. So no worries, we are going to mention first what is given in the question. So time is given, which is 15 minutes. All right. And what else is given? Speed is given, which is 2 meter per second. All right. So what we are going to do first, we need to calculate the distance here. So you already know from this root formula, that is speed equals to distance upon time. We need to know the value of distance. So what we will do, distance equal to speed multiplied by time. So our formula is speed multiplied by time. Now you just need to put the values in it. So you already know that speed is given like 2 into multiply by 15. So you will get the answer 30 meter per second. All right. So this was this question. Now we will see the next question. All right. So here the question is asking you to draw the shape of the distance time graph for the motion in the following cases. All right, we have already learned several graphs in the previous section. If you might have forgot the data or this distance time graph, so just go first and revise your concept. All right, where we have studied about the two types of distance time graph, in which we have studied about the constant speed distance time graph, and also we have studied when the car or any vehicle is at rest, so what the distance time graph will look like, right? So here in the first question it is asking a car is moving with a constant speed. All right, so we already know when the car or any vehicle is at constant speed, so the graph will look like this. You will mention like this. This is your time axis and this is going to be your distance. All right, so you already know at constant speed we always make the graph in this position, like this straight line, right? So this is the car moving at the constant speed, means number 1. And for the second graph, since the car is not moving at all, a car is parked on a side road, so it means it is at the rest position. So the graph will go like, please always mention the axis. This is time and this is distance, and the car is at rest, so it will look like this. All right, so this is your second answer and first answer. All right, now we will see the next question. So the question is, a car moves with the speed of 40 kilometers per hour for 15 minutes and then with the speed of 60 kilometers for the next 15 minutes. So first you need to check whether the SI units are same, or if they are not same, you need to change them. So you can see that they are same. You can see minutes are there, kilometer per hour, yeah. So the problem is here that minutes time is given and the speed is given at 60 kilometers per hour. So first we need to change them. First we will write every values which has been given in the question. So we need to mention first, right? Like speed is equals to 40 kilometers hour is given, right? And time here is given is equals to 15 minutes. So first we will calculate the distance 1, right? So in order to calculate the distance 1, you already know the formula, speed multiply by time. Now you're just going to put the values, which is 40, but you're not going to put 15 minutes here. You need to change it, right? You need to change it into the hour. So it will, by changing it, you will get how much? 0.25 hour, right? So you need to multiply this and you will get the answer, which is 10 kilometers. All right, and now in the case 2 or for D2, this one is S1, this one is T1. Now for speed 2, you need to mention it 60 kilometers per hour, and time 2, which is 15 minutes. All right, so now we're going to calculate distance 2, which is going to be speed multiply by time, and then again you need to change it 60, and 15 minutes will goes like 0.25, right? Here only we have calculated it, and then the distance 2 will be 15 kilometer. All right, so the total distance you need to calculate. So we have calculated distance 1 and distance 2, and then for the question is asking you about the total distance. So what we will do for the total distance, we are going to add D1 and D2 like this, right? And if you want to know how does this conversion happens, how we have converted the minute into hours, so this is a conversion unit. 1 hour is equal to 60 minutes and 60 minutes is equals to 1 hour, right? So what we have done here, since we have to calculate in 1 hour, So 15 minutes is given. So we have done 1 upon 60 into 15. So like this we have done, and we got 0.25, right? Like this. All right. So let us see the next question. Yeah. So it is this question states that suppose the two photographers shown in figure 13.1 and in figure 13.2 of NCERT had been taken at an interval of 10 seconds. Like, so the time is given, which is about 10 seconds, right? And then if a distance of 100 meters is shown by 1 centimeter in these photographs, calculate the speed of the blue car. So since distance is given as 100 meter, so you need to calculate the speed. So you just simply distance upon time taken, right? So distance will be 100 and time is 10. So what will be the answer? 10 meters. All right. So here's the formula is speed is equals to distance upon time taken. All right. Now next question. All right. So figure 13.15 shows that the distance time graph for a motion of two vehicles A and B, which one of them is moving faster. So you can see by itself, see whose graph is longer, whose line is longer, A. So vehicle A is moving faster. All right. Now, which of the distance time graph shown a truck moving with a speed which is not constant? Which is not constant, right? So you already know this is constant. This is at rest position. This is this, and then this is also constant position. This is also somewhat, because rest means it's in a proper speed in which it's resting, right? So this option shows third one. Third graph shows or depicts that truck is not at constant position. All right. All right. So let us see the next question. All right. So these are the some questions, statement questions. We have already done the numericals. So these are the some statement questions. Classify the following as motion along a straight line, circular or oscillatory motion. Motion of your hands while running. All right. So this is straight line, right? Next one, motion of a horse pulling a cart on a straight road. It is also straight line. Motion of a child in a merry-go-round. So you know merry-go-round is the ride which goes round and round. So it's a circular motion. Motion of a child on a seesaw, straight. It's also a ride. Motion of a hammer of an electric bell, which is going to be like a bob, pendulum. So it's a oscillatory motion. If you have having any sort of doubts in knowing which type of motion I'm talking about, so we have already discussed in part 1 in section 1 of this chapter. Please go, I'm going to mention that part in the description. Please go and check first that, and then come here and discuss or see these questions, right? Motion of a train on a straight bridge is going to be straight. If you have any sort of doubt, just look at that video first. Alright, so which of the followings are not correct? The basic unit of time is second, correct. Every object moves with a constant speed? No, right? Distance between two cities are measured in kilometers? Yes, true. It can also be mentioned in meters. So, the time period of a given pendulum is constant? False. The speed of a train is expressed in meter per hour? No, kilometers per hour. Alright, so it's false. So all right students, these were the questions. So till then, keep on revising and keep on learning. Bye bye.